All right, this is the recording for Math 222 for today. Sorry I didn't have it earlier. So I'm going to try to compress it. So it's a shorter video, hopefully. So let me see if I can go back and recreate what we have, but more compactly. All right, so 4.3, we have a right triangle, opposite, hypotenuse, adjacent, SOHCAHTOA. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. And these are the reciprocals. Cotangent, secant, and cosecant are reciprocals of tangent, cosine, and sine. Okay, some special triangles are the 45, 45, 90 right triangle, okay, where each of these I will call x because it's an isosceles triangle. So using your Pythagorean theorem, x squared plus x squared equals 1 squared. That gives me 2x squared equals 1. Divide by 2, x squared is a half. Take the square root. X is the square root of 1/2, or radical 2 over 2. So each of these is radical 2 over 2. So the picture now looks like this. This is 45 degrees or pi over 4. Both of these are pi over 4. This would be radical 2 over 2, radical 2 over 2. So that would mean the sine of 45 degrees and also the cosine of 45 degrees are both radical 2 over 2. Okay, for a 30, 60, 90 triangle, I start off with an equilateral triangle. Each one is side length 1. These are all 60 degrees. Draw a perpendicular right here. That means each of these is 30 degrees. This is 90 degrees. That means each of these is a half. And so my height, I decided to call h. That tells me 1/2 squared plus h squared is equal to 1 squared. 1/4 plus h squared equals 1. Subtract 1/4. H squared equals 3/4. Take the square root. H is radical 3 over 2. So the basic picture I now have is like this. Okay, so 30, 60, 90, radical 3 over 2, 1/2, and 1. So that means the sine of 30 degrees is a half divided by 1, or a half. Cosine of 30 degrees is adjacent, radical 3 over 2 divided by 1, or radical 3 over 2. Okay, so here's a unit circle I went over in class. 1, 0, 0, 1, negative 1, 0, 0, negative 1. The equation is x squared plus y squared equals 1. Here's 45 degrees, which is pi over 4. That means the x and y coordinates are both radical 2 over 2. If I go all the way around the circle, x and y here, 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 and here, they're also all radical 2 over 2 except for the sign, SIGN. Okay. Here's second quadrant, x is negative, y is positive. So that's negative radical 2 over 2, positive radical 2 over 2. Third quadrant, x and y are both negative. So that's negative radical 2 over 2, negative radical 2 over 2. And fourth quadrant, x is positive, y is negative. So radical 2 over 2, negative radical 2 over 2. Okay, and the angles are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so the x comma y is cosine theta, sine theta. Right, and based on the triangle that I had over here, that means over here at an angle of 30 degrees, this is the point radical 3 over 2, 1/2. If you can't read that, that's square root of 3 over 2, 1/2. At 60 degrees, they're reversed. This is 1/2 square root of 3 over 2. Okay, I'm going to go back to section 2, okay, section 4.2, question about coterminal angles or coinciding angles. Okay, two angles would coincide or they're coterminal okay, if they're 360 degrees apart or 2 pi radians or a multiple of that. Okay, for 15, one of the angles was 45 degrees. There's 45. Now where's 405? Well, 405 minus 45 is 360. They are 360 degrees apart. Therefore, they're coterminal. They do coincide. So if I go all the way around the circle, that's 360. Then if I add another 45, that's 405. Okay, so yes, they are coterminal or they do coincide. 17, the angles were 13 pi over 6 and pi over 6. If I subtract, I get 12 pi over 6, which is 2 pi. 2 pi is 1 revolution, 360 degrees. Okay, so they are coterminal. The answer is yes for 17 also. Pi over 6 turns out to be 30 degrees. So where's 13 pi over 6? Well, you would go 12 pi over 6, which is 2 pi, and then you go up another pi over 6. So that leaves me at 13 pi over 6. So 17 is again yes. So this is yes, this is yes. They do coincide. Okay. 19, however, is a no. Okay, the two numbers were 150 and a negative 240. If you subtract, you get 390. That's not 360, so they're not going to be coterminal. They do not coincide. Okay, so I wanted to give you that back. And now let me show you some problems from the new stuff. Okay, so section 3, hopefully. Okay, so question 1, they gave it to me like this: 2 radical 21 in theta. First find the hypotenuse, temporarily call it c. So 2 squared plus radical 21 squared is c squared. 4 plus 21 is equal to c squared. C squared is 25, take the square root. C is plus or minus 5, throw out the negative, these are distances, so C is 5. Then I do my SOHCAHTOA. Sine of theta is opposite over hypotenuse, 2 over 5. Cosine is adjacent over hypotenuse, so that's radical 21 over 5. Tangent of theta is opposite over adjacent, 2 over radical 21. And then you just flip them. Cosecant is the reciprocal of the sine, so 5 over 2. Secant is the reciprocal of the cosine, 5 over radical 21. You can leave it like that as far as I'm concerned, but if you want to rationalize the denominator, multiply top and bottom by radical 21. So that gives me 5 radical 21 over 21, but you can leave it like that. Cotangent, you flip the tangent, so radical 21 over 2. So that's all. Okay, problem 5 over here, they gave me 12, 13, and x. Find x. So x squared plus 12 squared equals 13 squared. Pythagorean theorem. 12 squared is 144. 13 squared is 169. Subtract, I get x squared equals 25. Square root, x is equal to 5. And once I have that, I can get the ball rolling. So sine of theta is opposite over hypotenuse, 5 over 13. Cosine of theta is adjacent over hypotenuse, 12 over 13. Tangent of theta is opposite over adjacent, 5 over 12. And they're reciprocals. Reciprocal of sine is cosecant, so flip it, 13 over 5. Reciprocal of cosine is secant, flip this, 13 over 12. Reciprocal of tangent is cotangent, flip this, 12 over 5. Okay, number 9, they give me this picture, 45 degrees, 7, and x. This is the opposite side. This is the hypotenuse. So I can say sine of 45 degrees is opposite over hypotenuse, 7 over x. Multiply both sides by x. X sine of 45 degrees is 7, divided by sine of 45 degrees. So x is 7 divided by sine of 45 degrees. Punch it in your machine, 9.899. And for this one, if you're punching in your machine, make sure that you're in degrees. Okay, then the next one was number 11. They give me this picture, 60 degrees, 6, and x. Find x. So this is the opposite side. This is the adjacent side. That sounds like tangent. So tangent of 60 degrees is opposite over adjacent, 6 divided by x. Multiply both sides by x. X tan 60 degrees is 6. Divide by tan 60. X is 6 divided by tangent of 60 degrees. Punch it in the machine, 3.464. Okay. All right, then problem 13. To give you this picture, this is the Greek letter alpha, A-L-P-H-A. This is beta, B-E-T-A. Okay. So find the rest of the triangle. Alpha is 30, BC is 8. Okay, so let me show you the picture now. This is alpha, A-L-P-H-A. This is beta, B-E-T-A. So if this is 30 degrees, this is automatically 60 degrees, right? They have to add up to 90 because this is already 90. So beta is 60 degrees. BC is 8. Okay, So I decided to go sine of 30 degrees is opposite over hypotenuse. So it's 8 over h. Okay. I just went over the sine of 30 degrees as a half, or if you were to do it, you can actually punch it in a calculator. But I change this to 1/2 equals 8 over h. Cross multiply, get h equals 16. So h is 16. Once I have 8 and 16, I can use the Pythagorean theorem to figure out the y. Right? So y squared plus 8 squared is equal to 16 squared, the hypotenuse. 8 squared is 64. 16 squared is 256. Subtract 64. Y squared is 192. Take the square root. Square root of 192. That's 64 times 3. Square root of 64 is 8. So 8 radical 3. Punch it in your calculator. 13.86. Okay, then 17D. So they tell me cosecant of theta is 3 over 2. And A, B, and C are similar. Okay? So cosecant is 3 over 2. I don't like cosecant. I'll do its reciprocal, which is a sine. Flip it. Sine of theta is 2/3. Okay, so I draw myself a triangle. Sine is opposite over hypotenuse. So sine of theta is 2 over 3. So I have to figure out this adjacent side. So I call it x. X squared plus 2 squared equals 3 squared. 2 squared is 4. 3 squared is 9. Subtract 4. X squared equals 5. So x is radical 5. X is the square root of 5. Okay, so now I can find everything else. I now have these two. They gave me that. Flip it to get that. Draw my triangle. And now I can find cosine. Cosine is adjacent over hypotenuse, so that's radical 5 over 3. Flip it, you get secant, 3 over radical 5. And then tangent. Tangent is opposite over adjacent, so 2 over radical 5. Flip it, you get cotangent, radical 5 over 2. Okay, so that is very quickly, okay, I know I kind of rushed it, but this is essentially what happened in class when I didn't record. So this is a recording of today's lecture.